So I say one question in the test, one graph is given, and you need to determine, look at the graph only, no mathematics, no nothing, only using common sense and imagination. What is the domain and range? Remember the idea for the domain. Domain is the set of the x value in which the function is defined. The bad guy is to be undefined. So you exclude undefined. And the range is a similar idea, but in y. So one fantastic way to do this is you take, and the curve is given. Okay, by the way, I give you complicated, no? Because include holes. Look, this is a holes. This is another holes.
Professor, the white screen is off.
It's off. Oh, wait a minute. You got me, guys. Remember, this is a virtual. To say, I share the whiteboard. Right, let me see again. Let me try again. Okay. Okay. Microsoft whiteboard. Start sharing. Do you see or no? No?
Yes.
Yes? Everyone saw that? Guy, help me.
Yes.
Okay.
Yeah.
Okay. Entonces ponen off the microphone. Entonces ahí say que when it's a whole, obviously in the whole the function is undefined. In the whole the function is undefined. And also it's undefined when you have a gap. What is the gap? And between 3 and 4, I can see a gap. Wow. Anthony, you connecting using the old link. In every lecture, I send a new link. It's also undefined. Therefore, to determine the domain, you take any point on the curve. Bam, 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 bam. Any one. And you projecting onto the x-axis, projecting onto the x-axis. So when I project it onto the x-axis, I can see that the x value is that bar. Stop here because we have a hole. So the hole is a hole like that, and the x-axis also. We continue here. And here no, because this is not the hole. Because this circle is open, but this circle is closed. So enclosed, yes, it's defined. And in one dimension, the idea is bracket when it's defined and parenthesis when it's undefined. And between 3 and 4, we have a gap. And the gap is undefined. Suppose I want the function in 3.5. No, not 3.5. This is completely empty. And we continue in 4, but in 4 we have again not included 4 because it's a whole, and continue forever to positive infinity. So the green part represents the domain. Let me try to express it. The answer in the test I need. Domain is from negative infinity, is this guy, comma, to parenthesis, because in 2 we have a hole, union between 2 and 3, not included 2, included 3, union because we have 3 pieces, parenthesis, 4 comma infinity post. Do you understand very well this? Yes or no? Yes or no? Let me know.
Yes.
Okay. Now let's
Yes,
move on.
Professor.
Okay. Let's move into the range. Range is similar, but now you're projecting onto the y-axis. The projection is in that direction. So I can see that we go from negative infinity. Here. But in 4, stop. It's a negative infinity. but in 4 stop. In 4, obviously, we have another hole. And in between 4 and 5, yes, you have interval. Include 5 because in 5 we have a closed point. Open, open like that, open, undefined, close, yes, define. Entonces the range idea is from negative infinity, comma, is there even class today? Even class. What mean even class? Infinity, comma, 4. Parenthesis, union, parenthesis, 4, comma, 5. Because in 4 we have a hole, so to be undefined. So actually it's from negative infinity to 5, but in the middle of the interval we have a hole in 4. And this guy, remember, is the interval notation. So always in the test I asked you express domain and range using interval notation. Remember, interval notation is the notation que we open bracket or parenthesis, depending si include or no the endpoint, and always you put in separate by parenthesis lower bound and upper bound. In this order, no opposite. O sea, it's totally illogical to say 5,4. Okay, no, it's 4,5. So lower and comma upper. Do you understand this or no? So one question you see in the test, right? What is that? Putting off microphone, please.
Which is steel.
Oh, mute for you, Mister. Werner, Werner. I immediately see your name. And don't put in on the microphone and you answer. You have question, yes. If you want to say something. But no noise. Okay. Entonces let's move on to another topic que es super important. Que es determine domain, pero using the equation. Important. Es determine domain, pero no range, because range is too complicated. Determine domain using the equation. One equation is given, and you have to determine the domain of this equation. Okay. I make a mistake here spelling determine. Okay, cool. Let's see what is the idea. The idea is, it's important to understand, guys. You assume que the domain is always all real number from negative infinity to positive infinity, except the restrictions. And what is that? Well, we have different kind of restriction, but in this chapter we study only 3 kind of restriction. Now the restriction, we have 3 categories, 1, 2, 3. The first restriction is when you have division to expression P divided by Q, okay, you need to avoid that Q never would be equal to 0, because division by 0 to be undefined. So 2 over 0 is undefined. So you need to avoid this. But this is only happening when you have division. So you have no division, no. Another possibility is when you have a square root of the one expression I want to call E. And this expression must be non-negative, positive or zero. Because what happens when it's negative? Negative 4 is 2i. And 2i is imaginary, completely out the supposition que is supposed to solve real number. So you need to avoid that situation. Restriction, restriction, restriction. And the last one is when you have division, que you have a square root pero in the denominator part. Entonces ese combination 1 and 2, que es the expression E must be positive. Because it's 0 division by 0, because it's square root 0 is 0. Now, entonces, this is the idea. Let's move on to the example to understand how we combine these three restrictions in one specific problem and determine the domain when the equation is given. For example, example 1. Example 1 is the one function, que the name is f of x, equal x plus 4 divided by x squared minus 2x plus 3. Oh, es obvio que you apply the restriction number 1. Que es the restriction when you have division. Entonces you need to avoid semicolon, que the expression at the bottom, que es q, x squared minus 2x plus 3, never would be 0. No 0 anymore. Then, this symbol I don't feel comfortable. However, no problem, I put equal sign because I feel super strong solving quadratic equation. In this case, the solution is easy by factorization. And the combination that opens the door for this factorization is 3 and 1. Because 3 times 1 is 3, and 3 minus 1 is 2. And the signs are negative here and positive here. Therefore, you apply the zero factor property, and each factor is equal to 0. So one solution is positive 3, another solution is negative 1. Actually, remember at the beginning, this sign is no equal. So it's no equal, no equal, no equal, and no equal. But positive 3 and negative 1 is a bad guy, it's a restriction. So to understand and interpret much better this idea, I propose you doing the sketch of the all real number line. This is all real number line. This is the supposition that the domain is from positive infinity, negative infinity. However, in the middle of the process, this is 0 in the middle. I investigate, we have two restrictions, n3, 1, 2, 3, and negative 1. Negative. Therefore, in negative 1 in positive 3, we have two holes. Now, my domain, let me use in the same color, is the rest of the number that have no problems. This interval, this interval, and this interval. And this interval is this piece. From negative infinity, comma negative 1, of course not include a negative 1, because a negative 1 to be undefined. The second piece is from negative 1, comma 3, not including both endpoints, and the last piece is 3, comma infinity. And you connect in this interval using union and union. And this is my domain. Everyone understand that? This is my first example, no? Okay, using the first restriction, that one. That one. I have example okay, using every restrictions. Guy, do you follow me?
Yeah.
Cool. Example 2. Professor, do you have to show word? Yes. And the written test, you need to show me the word in detail. And don't try to copy for another stupid students, because I detect immediately see the thing that you write is nonsense or is good. Nonsense. Look, exactly like me. Okay, working logical, right? It's the same. Using your own idea, no? Okay, example 2 is g of x equal square root 3 minus 2x. My equation is, what kind of restriction we using to determine the domain? Restriction number 1, restriction number 2, or restriction number 3? 1, 2, 3. All right, let me see. Right, but does have the B shown. Okay, guys, now I want to talk about mathematics now, okay? Any question about this? Yes, email me. You communicate with me, email me. Any particular question that you have, email me. Okay, got it, thank you. Sandra. What restriction we using, Sandra? Number 1, number 2, or number 3? No idea? Nobody have idea?
2.
2, because it's a square root, right? That's it. 1, what should I do? Well, you take the expression inside, que is 3 minus 2x. And this expression is, or must be, greater than or equal to 0. Similar to this idea. Non-negative. The expression inside, non-negative. Si es negative, I know it's complex or imaginary. No good. Now you're solving this inequality. This is minus 2x. It's greater than or equal to minus 3. Move 3 to the right-hand side. Divided by negative 2 both sides. Because my goal is isolate x. And remember, when you divide or multiply any inequality by negative number, the reverse, the inequality sign is reversed. It's 3/2. Okay, let me try to do my best here, because like that I cannot express it. I don't understand that. I understand in this notation, interval notation. So parenthesis, bracket, baran, comma, separate by comma. Let's do in the sketch. The sketch is, again, this is my Orion number line in the second example. Positive infinity, negative infinity. 0 in the middle. This is 1, this is 2, this is 3. But this 3/2 is 1.5. 1.5 is exactly in between, the midpoint between 1 and 2 here. 1.5. But it's to the left because it's less than. So it's to the left. And of course, different to this, include the endpoint. So include, and the symbolic way to indicate this is using bracket. Now my answer is then, domain for the example 2 is equal from negative infinity, comma, 3/2 or 1.5 either way, and bracket. Do you follow me? Do you understand this idea?
Yes, yes.
Example 3. Okay, in the example 3, we have another function that is called, the name is h of x. And this is 4 divided by square root x minus 9. So what do you consider is the restriction that you apply in this example? 1, 2, or 3?
3.
3. Remember, you have 3 scenarios. We have 3 possibilities. Expression in the denominator, no 0. Expression inside the square root, non-negative. And expression in the denominator and square root. Entonces es just positive. So you take, I don't care for, don't give me information. So you see I never using the numerator part, is not important, total irrelevant. I using only the expression inside, and this is greater than 0. No equal, because 9 minus 9 is 0, and 0 square root 0 is 0, and 4 divided by 0 is to be on the 5. This is x greater than 9. Therefore, one more time, I do the sketch because it's inequality. This is my Orion number line. infinity positive, infinity negative. 0 in the middle, but you have, suppose 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's 9 here. And this is to the right, because it's greater than, and of course, no including 9. It's not equal. It's parentheses. Therefore, our domain in the example 3 is, oh, music, no. Music, give me problem. See, hey, miss. No. Okay, music may be copyright law. Probably I cannot post this on YouTube. Okay. What? Okay. So the domain is from 9, not including 9, to infinity. Post. Okay. Do you follow me? Do you need another example? Yes, I suppose. Yes, I suppose.
More of the last.
Yeah. Of course, I have a lot of here, but one more is very convenient. Look, example 4, ¿no? Yeah. Entonces, let me call P, the function P. Remember, any function have a name. An expression associated is square root 2x plus 1 divided by x minus 4. Okay. Help me to understand this. You have restriction, yes or no? And how many restrictions you set up? How many? Remember, restriction 1 is division. Restriction 2 is square root in the top. The restriction 3 is square root in the bottom.
But it's gonna be
2 restrictions.
2 and what?
1.
2 and 3.
2 and 3, no.
It's 1.
Es 1. O sea, es division. You divide by x minus 4. It's like the first one. So 3 is when you have a square root in the denominator part. The second is when you have a square root in the numerator part. And the first one is when you have division. It doesn't matter if we have a square root or no. So it's obvious in this case, we have 2 restrictions. One restriction obviously is you take the expression in the denominator, the q, and this is totally illegal to be 0. And another restriction is you copy 2x plus 1, and it's totally illegal, so it must be non-negative, so greater than or equal to 0. Yes or no? This is restriction 1, and this is restriction 2. In this example, no? In other example, is more complicated. And you connecting this inequality by and, because you need to satisfy this condition and this condition, both together. Okay, no problem. To say use isolate, for example, the first one is x, no 4. That means in 4 we have a whole. And the second, no. The second one is 2x greater than or equal minus 1 divided by 2 divided by 2. X is greater than or equal negative 1/2. Okay, now let's do it. The sketch to see more clear. One picture much better give 1,000 equation, 1,000 word. Says real number. Infinity positive, infinity negative. 0 in the middle. I put 0 because it's a reference. This is the positive part and this is the negative part, no? And we have 4. 1, 2, 3, 4. But what happened in 4? We have a whole, no? And the whole we can represent like that. It's undefined. Because 4 here is 4 minus 4 gets 0. And division by 0 to be undefined. Now, the rest gets this inequality is a negative 1/2. The negative 1/2, I suppose, using my imagination. Let me make it zoom. This is negative 1, and this is negative 1/2. This guy, midpoint. Entonces es greater than or equal. Entonces greater than is to the right in that direction. But in 4 we have a hole. You know that. Here, hole. And continue. What happened with the negative 1/2? Include? Yes. How do you know? Equal sign. Therefore, bracket here. Bracket. Here. Now, the equation for the first part is that part is bracket negative 1/2. Incluye, look, comma 4. No include 4. Union 4, infinity. This is the domain of that function. This idea is more clear now?
Yes, thank you, Professor.
Cool. Now we study another topic. Guys, I want to come back again in the review. Review maybe we start today or no? I don't know. I suppose que no.
Professor.
Go ahead.
Are you extending the homework also?
Extending what?
The homework.
Yeah. I extending. The homework and the test. Yes. Sí, no, like a normal. Extending, pero I appreciate so much, mister. You remind me. You email me, Professor, okay? Because I made a little bit crazy and complicated. And maybe I forgot. Okay? I cannot. I suppose que no, but just in case. You remind me, okay? Okay, guys. So now let me erase the board. And we study new topic is easy also, but you need to understand very well. It's about piecewise function. Piecewise function is a function que we can define, pero no en only one piece, sino en several pieces. Piecewise function. One example to understand and the corresponding explanation. Suppose, what is the notation? Well, the notation is the name of the function again, but the definition is a little bit weird. We open a big curly bracket like that, and you copy expression, suppose x, suppose 1, suppose 3x, because this piecewise function contains 3 pieces, and this expression is valid if it's the condition between -4 and 0, including -4, but not including 0. The second piece is valid if x is 0, only for 0. And the third piece, que es 3x, is valid if x is greater than 0. What is the interpretation of that? The interpretation is, this is my famous ordinary number line. Positive infinity, negative infinity. However, we have inside this 3 interval. This interval, red color. This interval, green color. And this interval, blue color. Okay, so we start here, this is 0, 1, 2, 3, -4. At the first interval, get the red color start at -4 to 0. Let me use the color. Red color. This interval. Now the green is just a point. The green is just a point. It's just a point here. It's just a point. Because there's only one point, x equals 0. And the blue, no. The blue is the positive value is this, to infinity. Okay. Entonces, this expression que es x is using in this interval. This expression que es just one number, 1, is using n0. And this expression que es 3x is using in the rest, que es in the blue interval. Let me try to understand this idea. Suppose que you evaluate fn0, you evaluate fn1, you evaluate fn -1, you evaluate fn40, and you evaluate fn -2. Ok, entonces ahí hizo 0. Oh, 0 es this green interval, que es 1. Oh, the expression you associate, you select 0 is belong to this piece, es 1. I take this expression. 1, bueno, 1 no. 1 is associated with this piece because 1 lie here. 1, 2, 3, 4, 5. Therefore, the expression que I select is 3x. But I know que x is equal to 1. So I'm using this notation. It's a bar such that x is 1. Entonces es 3 times 1. Okay, 3. You follow me? So there one process in which you discover in what interval lie the number that you want to plug in. Now, after that, you select the piece que corresponde in this interval, and you evaluate plugging in inside this expression. Do you follow me, guys, or no? Complicated or no?
No, I get it.
Okay, -1. Bueno, -1, I suppose que here. -1 belong to this interval. Because -1 is in between -4 and 0. And you select the expression x, and you plug in -1. -1, no +1. I make a mistake here. -1. And the answer is so if you replace x for -1, the answer is -1. This is my first answer. This is my second answer. This is my third answer. 40. It's obvious que 40 lie in the blue interval. Because 40 is too big number. 40 is this, I suppose. So you select 3x expression, and you evaluate at x equal 40. So the multiplication is 3 times 40, 120. 120 is the answer. And -2, -2 is different. -2 belong to this interval. -2, look at that. That represents this, and you select that piece, que is x, and you evaluate such that x is equal to -2. And the answer is -2. Boom. Final answer. A little bit, you get the idea? Or no? No?
Yeah, a little bit.
A little bit. One more example to confirmation any concept, but I want to analyze more quickly. Suppose example 2 of the piecewise function. Okay, it's f of x again. It's from now 2 pieces. 2 pieces easy. X squared and 2x minus 1. And this is defined if x is in between -2 and +2, including both endpoints. And the second piece is defined if x is greater than 2. I need to evaluate in several points. F in -2, f in +2, f in +1, f in +3, f in 4, and f in 0. Okay, let's do it. Let me start for the first one. Number 1, f in -2. -2 belong to the red piece or blue piece? Red piece. So you select immediately the expression x squared, and you plug it in x equal -2. Be careful with the sign because it's -2 squared. It's +4. So be careful because minus 2 squared is not equal minus 2 squared. This is positive 4 and this is negative 4, right? Be careful with this. Now 2 positive. Belong to the red or belong to the blue?
Blue.
Blue. It's 2 positive. And 2, we have 2 here. Okay, I understand. However, we have no equals here and we have equal here. So actually, 2 belong to the red. Do you see the detail? Yes or no?
Yeah.
Okay. So one more time, you select x squared and you evaluate into positive. It's 2 squared get 4 again. It's a coincidence, get the same answer. And what about 1? What do you think about 1? Belong to the red or belong to the blue? 1, positive 1.
Red.
Red again. So the same selection. The only difference is that you plug in 1, get the value that I want to compute that. And 1 squared is 1. What about 3? This is number 1, number 2, number 3, number 4, que se evaluating 3. Number 3, x value belong to the red expression or blue expression?
Blue.
Blue. Entonces you copy blue and plug it in 3. It's 2 times 3 minus 1. 2 times 3 is 6, and 6 minus 1 is 5. What about 4? Evaluating 4. Belong to the red or belong to the blue?
Blue.
Blue again. Same expression. But the difference is now the x is equal to 4. 2 times 4 is 8. Minus 1 is 7. Bang. And what about 0? Belong to the red or belong to the blue?
Red.
Red. And the expression is x squared. Evaluate as 0. It's obvious que 0 squared is 0. Okay, entonces, conclusion. You determine in each element or value in the domain in what interval lie. Lie here or lie here. And you select the expression que corresponde. Just copy and plug in the value that is given. End the story. No more complication. And the review packet we practice. In the test, you need to do one problem of this, similar. Okay? Guys, no problema. Piecewise function. Okay. Go ahead. Question. Sandra. So many steps. Okay. Sandra, you are taking advanced mathematics. I said at the beginning, this class is hard. Okay, so it's not your level, you need to take another class. Okay, you can see in the test one, see it's your level or no, and you drop the class. They say no, don't expect 2 plus 2 equals 4. No. Sorry. Okay. Now transformation. This is important, extremely important and complicated. Transformation on functions. Okay. Actually, we have 4 kinds of transformation. Only 4. Fortunately. I want to explain in detail one by one. After I want to illustrate animation to see the motion because, you know, to understand much better, one picture is much better than 1,000 words. And after I have a lot of examples. Let me see the theoretical part. You have 4 kinds of transformation. The first one, which is easy to understand, is called vertical shift. Okay, what is that? Suppose that we have one basic function. Que is the function without transformation. However, you are doing some elementary transformation. That is, you adding, plus. Pero plus where? Plus in that part. Okay, this is equivalent to don't touch the x. However, the y you adding plus something. This is typical vertical motion. So you don't move ni to the right ni to the left. You move upward or downward. And depending the sign, no? See, A is positive. You move upward. So positive is upward. You see, A is negative, it's down. Make sense? This is the idea behind vertical shift. So you affect basically the y component and the x component stay the same. Therefore, the graphic is moving upward or downward, depending if A is positive or negative. Do you follow me? Yes or no?
Yes.
Yeah. I promise you see example. Now the second is horizontal shift. A horizontal shift is a little bit different. This is the reason that help me to understand the function notation. Look, this is my original function that is given at the beginning, the basic. However, I am doing transformation. What kind of transformation? You adding or subtracting, but inside the parentheses, B. And this is equivalent. Okay, you are doing the motion, but in this case, not vertical, horizontal. You're moving to the right or to the left. I want to prove in a few seconds. Okay, the motion is a little bit completely to the logical. Is when it's positive B, when the B is positive, you're moving to the left. And when the B is negative, you move to the right. Okay, so the point is x minus b comma y. Now the motion is in that direction, left or right. The motion in this case was in this direction, up or down. The motion is left or right. When the b, when you see the number you add in inside the parenthesis is positive, the motion is to the left. Unbelievable. I want to show you in the animation now. And when it's negative, it's to the right. Do you follow me? Number 3 is vertical. Again, vertical means that you affect the y. Vertical stretch. Stretch, compress, or reflection. This transformation include 3 categories: stretch, compress, or reflection. Entonces now is you have the function, but you multiply, no addition, no subtraction, multiply by c. C is a factor f of x. Entonces we have 3 possibilities. If c is a number greater than 1, so 2, 3, 4, 5, 2.5, it's obvious that you stretch. Stretch means that you enlarge vertical in the y direction. Multiply by 2 times, 3 times, 4 times. However, si c is negative, is less than 1, and 0, is compressed. The effect is clear. Suppose that this is the happy face. I multiply happy face by 2, but 2 in the y direction. So the point is x comma cy. You affect y in the factor 2, on the factor 3, on the factor 4. And my happy face now look like that. Okay? Because you multiply the y, but the x, no, the x stays the same. That is the reason it's vertical stretch, compress, or reflections. You multiply by a number less than 1, for example, 0.5, this is compressing, and my happy face now is smaller like that. No? This is 1, this is 2, and this is 0.5. And see, you multiply by -1 is reflection. And what means to be reflection? Reflection. Reflection, but reflection in this case about or across or with respect the x-axis. Okay, suppose that this is my happy face. This is the x-axis. And my new happy face after the reflection is like that. This is the x-axis. So the x-axis behave like a mirror. And the new transformation is the image of this. Make sense? And number 4, is the last one, fortunately, is horizontal. Horizontal, the thing. Horizontal, stretch, compress, and reflection. To make horizontal stretch, compress, or reflection, the formula is you take the original function and you multiply by d, the x value. Do you see the difference between this and this? You multiply the y by c. That means affect the multiplier, the c and the y part. In this case, no, you multiply with x. And remember, when it's inside the parenthesis, the operation is opposite operation. You see like an opposite operation. And the point, you see x over d, comma y. So you don't affect the y, you affect the x, but divided by d. Why divide? Because it's opposite operation. You multiply, you divide in the point. This is a reason to understand, because you add in here a subtraction. Inside is opposite operation. Outside, no. Outside is the same. Now, you have again now 3 categories. D greater than 1, D in between 0 and 1, and D negative 1. In this case, D greater than 1 is compressed, completely opposite. You see now in the animation. This is a stretch, and this is a reflection. But it's reflection, different kind of reflection. Reflection about y-axis. So in this case, the guy can behave like a mirror as a y-axis. Suppose que this, suppose the function like that. Now it's f of x, and f of minus x look like that. Same shape, but reflection about the y-axis. This axis, sorry. Okay, so let's move into animation to understand a little bit. I prepare for you some animation que I suppose illustrate very well this idea in Desmos. Let me try to do my best. Okay, I open my browser, Desmos. Okay, this is my account. And I try to find example transformation. Example transformation, I suppose it's this. Yes. Okay, there you go. Let me share the screen now. Switching to Desmos. Do you see Desmos? Or not yet? Just let me know.
No, yes, too black.
No?
Oh, no.
Worse?
Yeah, it works.
Okay, cool. Look at that. Suppose. Okay, this is example. No. Okay. Okay. Let me try this example. Oh, no, the conclusion first. To illustrate very well the motion and the animation, I create one weird function, but you don't care too much. This is a segment. If, for example, I copy this transformation here. So the original is blue. The points are green, but now the new one is A. I'm moving A. A is, let me try. A positive is, like that. Well, what about the points? The point here, no? Yeah. This is the, okay, cool. Okay, look. I'm moving A positive, and you see clear like a word, que es vertical shift. In this case, over because A is positive. However, if I change A to negative value, it's downward. Do you see yes or no?
Yes.
It's clear. It's clear, right? It's clear. Okay, cool. Let me see. Now, let me try to do a horizontal shift. Sorry, get the second transformation. Horizontal shift. What's going on? Oh, yeah, I understand. Okay, this is, yes. Okay, now B. B is 0, but B, when the B is, wait, I make it stay here. Okay, the point is no good. I don't know why. No good. No point. It's just a segment. Okay, in this case, B. I change B. When the B is positive, oh, we moving to the left. And when the B is negative, we moving to the right. Do you see the effect? Yes or no?
Yeah.
Okay. Now let's see. So far, we are discussing only horizontal shift or vertical shift. And shift means motion and no deformation. Stay the same shape. Now, the transformation number 3 is the vertical shift is C. Look at what happened. When the C is greater than 1, whoa, do you see? What is the name of this transformation? It is vertical, no? Vertical what? Vertical shift? No. Vertical stretch. Do you see this stretch? And suppose que C is less than 1, suppose 0.9, 0.5. Do you see que is compressed? Compressed, right? And si C is negative, oh, a reflection. Exactly, let me try to put -1. Do you see reflection? About or with respect to the x-axis. Repetition. Positive, vertical stretch. Less than, and positive also, but less than 1, compress, vertical. And negative is reflection. For example, intermediate value here is both, is reflection and stretch. Everyone follow me?
Yes.
Okay. Now on the last one. The last one is when you multiply, but multiply inside the parentheses. You are fed by the factor. When the C is greater than 1, do you see compress? Horizontal compress. When the C is less than 1, maybe 0.8 is stretch, horizontal stretch. Do you see? Stretch. Wow. And when the C is negative, is reflection, but in this case, reflection with respect, suppose -1 is nice, perfect reflection. Reflection with respect to the y-axis, and the y-axis behave like a mirror. Cool? Okay. So, si you understand the idea, the theoretical idea, behind the transformation. Let's practice in different examples I bring for you. For example, the first example. The first example, do you see Desmond, right? This is the last answer, so it's a square root. Okay. It's y equal square root. So this is the last. Look, the answer is given at the beginning. And so you need to understand, wow. We have different transformation. According to the order of transformation, we are doing first the operation inside the radical, is adding 6. Adding 6 means horizontal shift 6 units to the left. And finally, minus 5 means vertical shift 5 units down because it's negative. So you are doing step by step. You start for the classical basic square root function. Is this. Now you are doing the transformation number 1. And the transformation number 1 is x plus 6 inside the radical. That is horizontal shift 6 units to the left because it's positive. And finally, transformation number 2 is negative 5, que es vertical shift 5 units down. Bang! And the green one is the final answer after the transformation. You start for the original basic function without transformation. This function, remember, I provide one document is called a library of the function. And you can see the graphic of the different functions that we are using here in the structure. Do you follow me? Do you understand very well the idea in example 1?
Yes.
Okay. Let's move into example 2. The example 2 is more complicated. The example 2, the function is given is this. And you need to understand how many transformations I need to do according to the order of operation, guys. You are doing, so you recognize that our function belongs to the family of the quadratic function is this. By the way, let me try to plot that. Bang. No, not this. Not this. Only the original basic function. It's a parabola. But inside the original function, you see x minus 5. X minus 5 means horizontal shift 5 units to the right. Okay, one by one, step by step. Look at that. Boom. The red one is the first transformation. Okay, is repeat the name. Horizontal shift 5 units to the right because it's negative. The third transformation is negative 1. And the original we have negative 1. So negative 1 is reflection. Reflection about x-axis. So the blue is the reflection for the red after multiplication by negative 1. And finally, plus 3. And plus 3 represent vertical shift 3 units over. Bam. And this is my final answer. And this is partial answer that I using to derivate the final answer is this. The graph of this after the 3 transformation is this parabola. Okay, of course, open down. No? Open down. Do you follow me?
Yeah.
Okay. One more example. Cubic. Oh, cubic. Suppose que it's given at the beginning. It's given y equal this one. Y equal parentheses x minus 1 cubic plus 7. Uy. So I immediately understand that this is come from for the family for the cubic. The cubic look like that. But the first transformation is x minus 1, that represents horizontal shift 1 unit to the right. Green color. And finally, plus 7. And plus 7 is vertical shift 7 up. 7 up is like that. Okay, you're moving 7 unit over. This idea is clear or no? It's clear or no?
Yeah.
Okay.
Yeah.
However, I have 2 examples. 4 and 5 gets very complicated. I want to explain in the whiteboard. I come back to this to see the graphic. Okay, let me try. Switching to whiteboard. Okay. Okay, erase everything. Do you see whiteboard or no?
Yes, we
Yes,
do.
we do.
Okay. Suppose the example 4, no? And some example is weird or complicated to see the transformation. So the example 1, 2, 3 is obvious. Only looking, losing eyes, no algebra. However, there are special example, like that function, that I don't understand very well what is the transformation. Because I believe que es horizontal shift maybe, but I don't know si es to the left or to the right. And the reason I don't know very well si es to the left or to the right is because when you have that format, it's easy, no? But in this case, I don't know si es this or it's reflection maybe, no? Because it's minus x. Okay, entonces you need to definitely to see more clear. You manipulate some algebra. Entonces suppose que one idea is you factorization -1 outside, artificially totally. And we have x minus 5. Okay, let me try, let me verify if the idea I did was okay or not. So the thing I did was you factorization -1, okay, actually we have no common factor, but artificially I create -1 outside. Okay, -1 times x is negative x, and negative times -5, positive 5. Cool, this is equivalent 100%. However, it's more clear, at least for me, okay, we have number 1, we have reflection. Reflection about, of course, y-axis. Because it's the reflection que is similar to this idea. Look, and y equal minus f of x. So this minus is this minus. And also we have another reflection, another shift que es horizontal, right? Que es phi. But in what direction? To the right or to the left?
Right.
To the right. Very well. So I understand now. After this, I understand very, very well this. Let me try to do my best by hand and verifying decimals. Look, I know in the library of the functions the famous function basic y equal f of x look like that, the graph. This is my famous square root x, approximate. So you are doing the first transformation, the reflection. Well, so my function is now like that. This is the function y equal square root minus x, correct? Now using another color, maybe green, I am doing the last case 5 unit to the right. At that point, S00 is 1, 2, 3, 4, 5. This is 5, this is the point 5, 0. And my new graph look like that. Okay. So we have two transformations. The original is the red one. The second is the reflection. We respect the y-axis. And the third is the horizontal shift 5 unit to the right. Clear? Yes or no?
Yes, Professor.
Cool. But let me try to see in decimals. I suppose it's enough of the transformation because I want to cover another topic. Let me try to share decimals for you. Okay. Do you see? Oh no. You see or no?
Yes.
Yes. Let me try example 4. Okay, there you go, there you go, there you go, there you go, there you go. Listen to the final answer. Remember, this is the, suppose this is giving at the beginning in the test. So it's confusing. However, I manipulate algebraically in the piece of paper like that. However, at the beginning we have a square root function. Bang. We have reflection. Bang. Let me change the color, blue. Now I have the famous horizontal shift, a unit to the right. Bang. And it's a green color. And by the way, I want to illustrate very, very important. Let me delete that part and delete that part. And these are 100% equivalent. Let me show you. Look. Do you see that si I put green, green, overlap, and you see only one? Look, it's the same. Do you see it's the same? So not always is possible do the transformation graphically and the equation gets given. Sometimes we need to do some algebra additional to see more clear. Okay. Let me try to come back to the whiteboard. No. Okay. Cancel. Whiteboard. Okay, what the hell? There you go. Do you see my whiteboard? Yes or no? Okay. Okay. Now we have another topic, is easy, super easy, que es a combination of the function. I want to explain quickly because it's straightforward. It's a combination of the function. So we know the functions. We have now two functions. And two functions form a new function, or three functions. Okay, it's a combination of the function. Combination how? In plural. Several functions. Combination how? Well, first of all, I want to explain using arithmetic operation. So addition, subtraction, multiplication, division. But after I want to complicate more. Okay, look. Suppose we have at the beginning two functions. F of x and g of x. And we have four possibilities to combine. The first one is addition. So this is you adding f of x plus g of x. And the symbolic way to indicate this idea is like a f plus g of x. It's another notation. Important. That the domain of this new function, the combination, domain is domain of f intersection domain of g. So it's the connection. No? So you have domain of f and domain of g is the common part. Always happen, always. Because it's satisfied, si it's completely out, the domain of f is totally undefined, at least one part. So see, this is undefined, and this is defined. It's obvious that the combination is undefined. So it's intersection between two domains. Always. No, always. In one scenario is different. Number two is subtraction. And the notation that we are using to subtraction is f minus g. It's important that you be familiar with this notation because in the test, I ask you the question in this notation. So you need to understand what I mean that it's subtraction. And domain is exactly the same. Same. of this. Satisfy both domain. Multiplication, bueno, okay, multiplication. F of x times period g of x is f times g of x. And the domain, again, is the same. It's obvious, right? But the division, no. Division is f of x divided by g of x. And the notation is f division g parenthesis of x. But the domain is a little bit different because it's the domain of f intersection domain of g intersection when the g is not zero. Remember that the denominator is totally illegal to be zero. You divide by zero, si g is zero, entonces completely undefined. Let's see example to understand the combination. It's easy, it's clear, but let's do it. Because in the test I want to ask you. Suppose that one function is given, example, only one, because it's too long. Suppose that f of x is 1 over x plus 3, semicolon, and g of x is x over x plus 2. It's obvious, looking this, that the domain of f is all real number except -3. So basically, in -3 we have a whole. Yes or no? Let me write in that way, it gets more clear. More clear, no, more easy. No interval notation is more complicated. Actually, in -3 we have a whole because -3 plus 3 is 0 in the denominator. Likewise here, domain of G is x such that x non-negative. Okay, this is important because I need to know this. Okay, so now, suppose I need to find f plus g of x in the test I asked you. Okay, no problem, I understand. And stay important. Find expression. Find the expression that represent the combination of that two functions. And important, stay is domain. Right? Well, this doing. This is you adding 1 over x plus 3 plus x over x plus 2. You can leave it like that, but more elegant is combine both expressions, so condensing this expression in only one. So you, for example, you find the least common denominator is x plus 3 times x plus 2, and you find the numerator part is this divided by this times 1 is x plus 2 plus x times x plus 3. Do you follow me, guys? This algebra or no?
Yes. Yes.
Of course, I feel no. Let's doing a distributive property and combine like that to write elegant expression. So is x plus 2 plus x squared plus 3x. Okay, almost I finish. You organize in descending order degree 2, 4x because 3 plus 1 is 4 plus 2 over x plus 3 and x plus 2. In the denominator, if you want, you can apply 4, but no, so you leave like that. In the factory form is nice. Now, what about the domain? Well, domain is obviously the intersection that situation and that situation. Therefore, the domain of the famous f plus g function is all real number except the 2 by guy that we have in the problem is -3, no -3, and no -2. Clear? Always happen. Always happen.
Can you do one more?
Yeah. Of course. Suppose the same example, but I want to illustrate F division G. Okay, F division G have extra. And the same question, Miss, find the expression that stays domain. So now it's division. Division who? Division 1 over x plus 3 divided by x over x plus 2. No, leave it like that. You are doing division. You copy the first exactly the same time. You reverse it, flip it, reciprocal the second. Okay, entonces es x plus 2 over x times x plus 2. Bam! And this is my expression similar to this. But what about domain? Domain F division G is equal. Remember, in the division we have extra restriction. Is domain of this is. Sorry, let me erase this. Is. Open the curly bracket, x such that x no 3, no negative 3, sorry, negative 3, exactly like this. And no comma, separated by and, because it's intersection. You need to satisfy that condition, and another condition is 0. Because 0 here divided by 0. So you copy exactly the same, and you include one extra, is 0 because this is 0. Okay. This denominator is 0. This idea is clear or no?
Yes.
Okay. Entonces, but I want to complicate a little bit more. We have another way more complicated and useful to combine the function, que es using function composition. Function composition. Spelling is correct? Yes. Function composition. Guys, pay attention. This is important. In calculus. Function composition. And the symbolic way to indicate function composition. So you have two functions. Suppose. Another function, G. And you put together. But how? Composition. What means composition? Composition means can you put one function inside another function. What is that, the inside, professor? So the notation is a little bit weird. You put, for example, F 0 can indicate composition. Actually, it's not 0, it's symbolic way G of X. What indicate this? Indicate okay, we have two functions, but the order is important. The G is the first one. The G is the innermost. And the F is the second. So the ordering is extremely important. Because you can combine like that. G composition F is completely different. In this case, the first function is F and the second is G. Don't worry, we explain different example to this. No, don't worry. So when you have that situation, this is equivalent to say F is the outermost, G is the innermost. This is another way to understand this notation. It's the same. But the important thing is it's one function inside another function. And the other important thing is the order is extremely important. In general, G composition F of X is not equal. F composition. It's completely different. In some particular example, maybe yes. But it's very, very weird. Let's see example to understand composition and how we manipulate that. Suppose this. Suppose f of x, this is example, guys. Example of the composition. Suppose que es x squared plus x plus 1. Semicolon, and g is 2x plus 3. Oh, it's easy. It's a linear function, quadratic function. Yeah, I want to find f composition g. Okay, and why not? Let's do it in an opposite direction after. But step by step. So basically, I realize the function g is the first one, and the function g is this, and this function go inside this. So you replace 2x plus 3 gets g and the x, and you have 2x plus 3 squared plus 2x plus 3 plus 1. You follow me? Do you understand the thing I'm doing or no?
Yes, I got it.
Okay, now the rest is just cosmetic. You FOIL that part, 2x plus 3, 2x plus 3 is 4x squared plus 6x plus another 6x plus 9, 3 times 3. I copy 4x squared plus 12, because 6 plus 6 is 12, plus 9 plus 2x plus 3 plus 1. Well, this final expression is 4x squared plus 14x plus 13, because 9 plus 3 is 12, 13. Wow! And this is an expression that represents the composition in that order. And state is domain. Always state is domain. This is the complicated part. Domain of this is a little bit different. Domain of this is domain of G, guess the first one, intersection domain of the new function. What is the new function? This is the new, after the transformation. And G is this. But in this case, in this specific elementary trivial example, G is linear function. Okay, you know that the domain is all real number, because we have no restriction. Remember, we have restriction only when you have denominator, when you have radical in the top or in the bottom. And this is a quadratic function that is also all real number, the domain. Entonces now the intersection in between all real number and all real number obviously is all real number. Now this is trivial. I want to complicate a little bit more. Another example. Okay, everyone understand. Okay, for example, when you see it's polynomial function, linear, polynomial, quadratic, the domain is all real number. Curiosity. We continue the same example, but we are doing backward. No backward, no in the other order. I change the order. G composition F. Always. This is a typical example in the test guide. No sophisticated, no complicated. Let me try. You erase that part, erase that part, erase that part. Okay, now what's going on? So I need to take the innermost function, that's F, and replace here in the x place of the second function, okay, now es G. Oh, entonces es easy. Es 2 times paréntesis x squared plus 1 plus 3. Do you follow me? 2x squared plus 2x plus 2 plus 3. The expression is 2x squared plus 2x plus 5. Bam! And this is my second expression. You see it's completely different. And this is more popular, it happened. Not necessarily this and this is the same. No, not the same. And the domain again stay all real number, because we are talking about polynomial function. It's easy, pretty easy, elementary. Guys, everyone follow me or you are tired?
Following you.
Okay. Let's do one more example. Okay, one more of the composition. Okay, composition, the interpretation of the composition is you have two functions. Look. And the function you try to believe is the black box. In the black box, you have input domain, and you get output range. Output. Now suppose that this function is g. Then you plug in, for example, I don't know, 2, x equal 2, and you get y equal 5. And we have a sequence of the function. This is like a change of function. We have 2, 3, 4, in this case 2. Case f is my second. You see that the order is important. This is my first function. This is my second function. And this phi now believe like a x, no y anymore, because it's the new domain of f, and give me a new y output. Okay, I don't know, it's 7. That depending of the function, no? You plug it in here. This is the idea. Entonces, the domain of the composition in this order, que es f composition g, is domain of g intersection domain, the new expression que es formula for everything. I copy here. Okay, let's see one, not too elementary, it's more complicated. No big deal, but more complicated. Suppose now that we have two functions. Example 2, no? 2, no? 2. F of x is equal 4 over x minus 1. Semicolon, g is x over x plus 3. Well, let's hope you're looking this. Okay, the domain of f alone is only a number except 1. 1 is a bad guy. No 1. Because 1 minus 1 is 0. Division. Restriction number 1. And domain of g is all real number except such that x non-negative 3. Because negative 3 here plus the 3 is 0. Again, division by 0, restriction. Now I need to find, investigate f composition g. So we have in state is domain. So we have two answers. Answer number 1 is expression. Answer number 2 is domain. Domain of who? Domain of the new function is given by this. Okay, let's do it. Entonces, immediately, important, the order. G is the first one. Entonces, now this expression is the first one. I try to use another color, a red color. Substitute here in another function. Entonces, we copy 4 over x plus 3 minus 1. You following? Okay, I try to do my best here, algebra. 4 is 4. And you find at least common denominator in the denominator part, and the bottom part. Entonces, x minus x plus 3. 4 over x minus 3 over x plus 3. Ooh, something weird happened. This x cancel out and stay 4 over minus 3 over x plus 3. Okay, good. Now leave it like that. No. You copy 4 over 1, is the top part, it's a whole number, that is the reason I put 1. Yeah, flip it that, it's x plus 3 over negative 3. The conclusion is 4/3 negative x plus 3. Oh, it's easy. This expression is linear. If it's linear, because degree is 1, the domain is all real number. No restriction, no fraction, no division. So this is the new expression. This is the, and that part is the, remember, domain of the new expression is orient. Therefore, see, we have no restriction in the new expression, it's because the domain of the composition is equal to the domain of G. So the dominant, the guy can determine what is the restriction is G. But I know who is G, is this. Therefore, the conclusion is the domain is exactly domain of G. And domain of G is all real number etc. Is, you know, suppose que en the test que es picky, que say you express it in interval notation. Okay, let me try to do my best. You copy the all real number line to understand much better the idea. This is the all real number line. Now, this is positive infinity, negative infinity, and the restriction is in -3. 0, 1, 2, 3. And -3, we have a hole. A hole. Now, and the rest, we have no problema. Everything is better, cool. Entonces, my domain is the part que I highlight in red color. Is this piece. This piece is from negative infinity, comma -3 parentheses. Union from -3, comma infinity. This is my domain for the composition. Okay, by the way, it's the same of the domain of G because the domain of the new expression is all real number. Guys, I propose you Tuesday we continue. No, we are doing the review package. Okay, we are doing the review package at the beginning, right? We have time. No, we have only 5 minutes. And the 5 minutes we can do something or no?
Yes.
No? Yes.
Yes.
Okay. Let's do something in 5 minutes. Let's do something que es the review package. I have the review package here. Let me try to do my best. June. Where is the review package? Here. In my desktop. In the Spring 2023. In the subject MAC1106 review package. Bam, I got it. Look. Do you see review package? At least the first page?
Yes.
Excellent. Let's do in the question number 1. Es piece okay. Square root -16 times square root -25. Immediately you see negative number inside the radical is imaginary. It's a 4i multiplication 5i. It's a 20. 20i squared. But I know very well that I squared is real equal -1. Therefore, the answer is -20. End the story. Do you follow me? Cool?
Yep.
Let's do it in the second question. The second question, piece okay. It's square root -81 times square root -9. This is 9i. This is 3i. This is 27i squared, que is equal -27. Boom. End the story. How do you feel? I suppose that in the test, one question is similar to this. Okay? Guys, this is a moment to ask me any question. Okay? Let's do number 3. I don't know what happened in number 3. That some students failed. Because it's easy. It's always the same. You adding or subtracting some complex number. But the student, I don't know why, try to do using FOIL. No! FOIL is multiplication. This is addition. The only thing that you should do is remove the parentheses with the corresponding sign, of course. This is positive, stays the same, but this is negative change. And this stays the same. And you combine real part Real part and real part. 5 minus 1 is 4, and 4 plus 2 is 6. And imaginary part. Imaginary part, imaginary part, imaginary part. Positive A and negative A is 0, cancel out, and stay 10A. Final answer. Any question? No problema. Everyone follow me so far?
Yep.
Yeah.
One more.
Yes.
One
Yes.
more. One more. The last one.
Yes.
3 minus 4i times 2 plus I. Oh, this is multiplication. A multiplication, yes, we apply FOIL. 3 times 2 is 6. 3 times 5, 15. Of course, 15i, no? This is minus AI. And this is minus 20i squared. One more time happen. The I squared, I need to know que es negative 1. And you replace, in this next line, you write 6 plus 15i minus AI plus 20. Because I squared is negative 1. And another negative 1 that you have in the front, together is positive 20. Now we combine one more time. Real. 6 and 20. 26. And 15. Positive and negative A is 7. 7i. Positive, of course. And that's it. That's the answer. Cool. Well, guys, you try to working. Remember, try to working online. Try to working. Any question? Let me see what one lady asked me a question. Jamie Martinez, no? Jamie, you are here. Left. Okay, guys. Bueno, bye. Let's see Tuesday, next Tuesday.
Thank you, Professor.
Okay, bye.
Professor,
Go ahead.
are you going over the rest of the review on Monday?
No, Monday, no. Monday, sorry. Sí, Monday. Sí, yes, Monday.
Okay.
Don't worry, I finish.
Okay.
Okay.